Hello everyone. Hope everyone can hear me clearly. Hope I'm audible to everyone. Hello everyone. Hello. Within a 1 minute we are going to start. Okay. Okay. Fantastic. So yesterday's session we don't have any quiz for yesterday's session. Today's session we have a quizzes. So definitely after the session you will get the quiz. I'm good guys. I'm good. I'm good. Hope everyone can see my screen now. Okay, we are going to start guys. Okay. Nice. Okay, so let's just talk about a little bit what we have covered yesterday, right? The the yesterday basically we have covered about the Python libraries, right? What exactly the Python libraries are? Why do we need to use Python libraries, right? Why do we require those, right? What are the benefits, right? And what kind of tasks we can do with Python libraries, right? What are the pros and cons of Python libraries, right? Pandas, NumPy, scikit-learn. These are the libraries we have discussed yesterday, right? Like a data frame as well. What about series? A little bit about the file handling as well, right? We have covered these other steps yesterday. Okay, the sklearn, file handling, how to import, basically how to read the data in Excel, in Python using pandas, right? The CSV file, whether it is Excel, whatever that file we have seen how to clean data in Python, right? On the iterate over a data frame with the help of apply and lambda function, right? These are the stuff we have talked yesterday. Okay, we make a function. After making a function, we have applied that specific function to the whole data frame, the every specific row for that specific column in a data frame. So these are the stuff we have covered yesterday. Now we'll just talk about today. These are the steps. Okay, just for the sec. So today's session, we just talked about what exactly ML algorithms are, right? What are those algorithms we have? Everything these are the so we are going to see, right? Like uh, algorithms like what is regression, what is classification, what are the libraries we have in Python for basically for solving a regression problem and classification problem, right? So now, before going to deep dive related to regression, related to classification, first of all, we have to understand first what exactly the data is, right? What exactly the data. So data is basically there are two types of data we have mainly, right? The first one is categorical, another one is continuous, right? Categorical data basically means understand there are multiple types of data we have, but generally there are two types of data we are going to work. Okay, there are multiple types of data, but for now we are just going to talk about the two types of data. Okay, pretty much simple till now. So today's session we are going to talk about the two types of data we have generally used for classification and regression problems. Okay, there are two types of data. First of all is categorical data. Categorical data basically means which is used for the classification purposes, right? Right? Which is used for basically for classification purpose. Continuous. There are continuous data as well. Continuous data basically used for regression purpose. If we have a regression problem, classification problem, at that time we will use a categorical data and continuous data. Okay, so we have understood in this manner. Okay, what exactly the categorical data are, continuous data are. Categorical data basically used for not no basically we are not going to discuss about discrete type of data as well. Yeah, these are related to each and every stuff, right? Now for today's one, okay, I'll express you that thing as well. So there are two types of data we have, mainly qualitative data and quantitative data, right? So see, qualitative data basically have a discrete data. Discrete data basically means this one. Discrete data which contains a number of students in a class, the number of workers in a company, the number of home runs in a baseball game, right? Mainly two types of data we have, qualitative and quantitative, right? Qualitative data has a two more types, discrete and continuous. Continuous data basically, which is used for the regression purpose if we have a regression problem. What exactly regression problem is, we will discuss that thing as well. But for now, we are understanding a data, what type of data we have generally. Qualitative data basically has the two main types, nominal data and ordinal data. Okay, nominal data basically which contains in this way. Okay, okay, okay. Okay, okay, for sure. Just give me a sec, guys. There's a noise. Just a sec. I believe there's no noise for now. Sorry for that, guys. There's some background noise. Okay. So now, hope that's clear till now. There's no noise, right, guys? Okay. Yes, I have checked. So I believe there is no noise from now. Okay. Okay. Thank you, guys. Thank you. Okay. Sure. So we are talking about the two types of data we have, right? Qualitative and quantitative. Qualitative data basically we have a two types, nominal data and ordinal data. Again, there is a noise. Okay, guys, just a second. Can you please confirm, guys? I have checked my mic again. I have reconstructed. Now, am I audible, guys? I just mute myself for a second because I'm just adjusting my mic. Can you please confirm, guys? Is it audible clearly? Okay, okay, guys. Okay, thank you. So we are talking about the data, right? There are two types of data we have mainly, right? Qualitative and quantitative. Again, this is the important one as well, right? We have to understand what exactly the data type, what exactly the types of data we have. Discrete data and continuous data. Continuous data basically used for classification problems. What exactly the classification problems are? If we want to basically find out whether a person is going to fail or whether a person going to pass, where we have a categories. Again, continuous data nothing but where we have a categories of a data, whether I'm going to fail or whether I'm going to pass, right? In this way, this is called a categorical data, right? You can say in this way. Okay, so these are the four. I'm not going to discuss about overall like what exactly nominal data is, ordinal data is. Now we are just talking about the continuous and categorical data for sure. Okay, so categorical data is nothing but the classification purpose it will use, right? Categorical data is a data which is basically used for the classifications problem. What exactly the classifications problem? where we want to predict a classes. Classes basically means, let's suppose I have a two class. Two class basically means whether a person is going to fail or pass. Two class only, right? This is called a classification problem. If I have a continuous data, based on a continuous data, I can solve a regression problem. What exactly regression problems are? Let's suppose regression problem in the way you can understand. I want to predict a house price. I want to predict a price of a house based on its features. What kind of features? Let's suppose I want to predict my house price based on how many numbers I have in my home, right? How many uh, how many fans I have, it, what is the locality of my house, right? How far a petrol pump is far from my house, right? What are the is like nearby, how many schools we have, how many colleges we have, right? The price of my house is basically depending on these kind of categories, right? These kind of things. How many bedrooms? Yes, how many bedrooms? So these are called the features, right? So the number or the price of my house is basically depend upon these are the features, right? Yes, what are the square feet of my area of a house? Yes, these are the features. This is called a regression problem where I have a continuous data. Getting a point where we have a classes, whether I'm going to fail, whether I'm going to pass. This is called a classification problem. And classification problem contains a categorical data. And regression problem, if we have a regression problem, at that time for sure we have a continuous data. We have understood till now, right? These are stuffs we have understood: categorical, continuous, or classification problem, or regression problem. Now we have understood classification and regression problem for sure. Okay, pretty much simple. Now let's just talk about classification versus regression. The same example I have gave you, the same I have here. Let me just decrease the size. Now you can understand this way: classification versus regression. I just already give you an example. Again I'm repeating classification, because if you have understand this thing clearly, at that time you can apply any number of like any algorithm of regression or classification, anything you can apply, right? So now just understand this way: classification is basically nothing but predicting whether student is going to fail or a pass. There are classes, right? Where we have a classes where I want to predict whether a person or a student is going to fail or pass based on their previous history. Previous history basically means how many classes he has attended, right? And the previous exams, how much he has scored, in these ways, right? We are not talking about the previous thing. I'm just talking about the classification. What exactly the classification problem is? I'm talking about the classification problem. Classification problem where I want to predict I'm going to fail or pass. There we have a two class, okay? And regression is nothing but predicting the percentage of a student. Again, this is a continuous. Regression problem is basically requires a continuous data. Continuous data basically means you can understand in this way: a percentage of a student maybe varies, right? Maybe varies till like 60% to 70%. It will not be fixed, right? Based on the data. You will get to know the basically the IPYNB file for sure after the session. Don't worry about that, right? Some people are asking about the classes notes. For sure we'll share that thing. So regression problem we have understood, where I have a continuous data, right? Predicting the percentage of a student based on the previous history, getting a point based on the previous scored marks, right? In this way. So now we have understood what exactly the classification problem is and regression problem. Again, two things you have to remember first. Classification requires a categorical data. Categorical data basically means where we have a classes, one class, two class, or there are many, like there are n number of classes, like five classes, 10 classes, three classes, based on the data, right? And regression problem requires a continuous data, where we have a continuous data, the price of my house, in this way. Getting my point? So now we have everyone get understand what exactly the classification is and what exactly the regression is. Hope everyone gets clear till now related to classification and regression. Right, guys? Okay. Okay, great. So now let's just see this thing as well. See, this is the classification problem, a graph of a classification problem, and this is a graph of a regression problem. Regression problem, basically, as we know, the regression problem requires a continuous data, right? In classification, you can see in this way as well. In classification, there are two classes. So see, this is a one class, this is a first class, and there is a class two. So my model, whatever that model we have in machine learning, right? I'm right now, I'm not talking about the models, I'm talking about the classes, right? So this is a first class. Let's suppose I have applied some classification problem, or not problem, classification problem, classification model, sorry. If I have applied a classification model at that time, it is predicting the two classes. I have a two class in this way. Getting my point? And there is a regression problem, which is basically fitting up a best fit line throughout my data points. Now we have cleared. You can see in this way, there are two charts I have, and there are two charts, and those two charts showing clearly this is a classification problem where we have a classes, and there is a regression problem where we have a simple straight line, right? Where I'm going to predict, right? Something in this way, right? Now let's just talk about, so now we have understood what exactly the data is, right? What exactly regression is, right? Regression is, and what exactly classification is, right? Getting my point? Now let's just talk about a machine learning stuff. So now today's one, we are going to discuss about the machine learning models. Okay, we'll talk about some one or two three models or machine learning. So now hope everyone get to know this thing as well, or if not, definitely I'm going to tell you. In machine learning we have a two parts, right? We have a more than two parts as well, but now we are just talk about the two parts. The first is supervised and second is unsupervised, right? And supervised, in supervised machine learning, basically we have a model named linear regression, right? They are much in supervised, we have a linear regression model, right? Linear regression, hope someone has basically done this thing as well in your 10-12 standard, right? The formula of linear regression is nothing but y is equal to mx plus c. If you don't know about the linear regression, I believe some of you have done that thing, right? You have heard about this formula, y is equal to mx plus c, the formula of a linear regression. Linear regression, yes, linear regression, in simple words, I'm just telling you, linear regression is nothing but this is the best fit line only. This is the best fit line. Again, linear regression is nothing but, in simple terms, it is a best fit line throughout our data points. Simple. If someone asks you what exactly linear regression is, linear regression is nothing but it is a best fit line. Linear regression makes a best fit line throughout a data point. Simple, right? How? You can see this thing. So see again, so this is my, so see, let's suppose this is my square feet, you can say. I'm just taking an example. So this is my square feet of my room, right? Like 15 feet or 15 square feet area I have in my room, right? 10 square feet area I have in my room. Based on that, what will be the price? So if I have a 10 square feet of an area in my room at that time, okay, the price would be this around. If I have a 15 at that time, the price would be varies around till this one 15,000, whatever it is, right? Getting my point, guys? If I have a 20, let's suppose if I have a 20 in future, we are predicting, right? In future, let's suppose I have a 20. So my linear regression model or linear regression model will be predict what will be the, if I have a 20 square feet area in my home, at that time, what should be the price at that time? This will be predicted, right? In future, based on my previous data, based on my previous data. So this line goes in like this line goes like this, somewhere about a little bit the deeper one or the higher one, based on my data. We are just understanding what exactly linear regression is, right? How it works. We are not going to in depth what exactly linear regression works. I'm just giving a basic overview about a linear regression, right? In linear regression, it is nothing but linear regression. The name already suggests, right? Linear, where we have a linear line, right? And regression, we know that linear regression requires a continuous data. Continuous data, right? Okay, now we have understood this thing, right? Clearly, everyone? Hope this clears for everyone, right? Linear regression is nothing but this is a best fit line throughout our data points. Simple. Okay. Now let's just read about a definition. Okay, great. Now, linear regression is a machine learning algorithm based on supervised learning. We know that machine learning has a multiple parts, right? Supervised, unsupervised, semi-supervised, or reinforcement learning, many modes, right? Now, you know, you have to understand this thing as well, right? In supervised learning, we have a multiple models, and one of them is linear regression. So, linear regression is a machine learning algorithm based on a supervised learning. It performs a regression task. Again, if we have understood what exactly regression is, at that time you can easily understand, okay, it performs a regression task. Regression task basically means, okay, where we have a continuous data, right? In this way, regression models a target prediction value based on independent variables. Again, whatever that model we will discuss, whatever that model we will apply, for sure at that time we have a two parts, right? The first one is target variable, the second one is independent variables. Again, whatever that model we are going to use for our prediction, at that time we have to split our data set as well. We have to split the data, and another step is to basically, we are two steps in this. First, you can say not step, two parts. First one is dependent, or dependent, you can say target variable is nothing but the dependent as well, right? And another one is independent features. You can say variables are nothing but the features. If I'll say features, features basically mean the variables. Variables basically mean the columns of my data frame, of my data simply, right? So it is mostly used for finding out the relationship between the variables and forecasting. Yes, linear regression also used for finding out the relationship as well between the two variables. Between the two variables. Again, you can understand in this way. I'll give you an example as well. So this is my one feature. Again, this is my one feature. So see, this is y is nothing but my dependent variable. Dependent variable basically means my target variable. Whatever I want to target, whatever I want to predict, this is called a target variable, right? And this is called my independent variable. Okay. So see, independent variable basically means what will be the price. So how it is target? Target basically means I want to predict this one. I want to predict the price of my house based on the number of my rooms. Let's suppose I have a 20 rooms at my home. At that time, what should be the price? Price should be 20,000, like this, right? If I have a 5 rooms in my house, at that time, what should be the price? Price should be like this. Price should be around 7 8,000, whatever, right? In this way. Getting it, everyone? Are we clear till now? Can anyone basically confirms what exactly like we have understand this thing? Okay, guys. Okay, great. Now let's just move ahead. So now we have discussed these things as well. Let me just do this. Okay, now just see this graph as well. Now, as I told, linear regression is nothing but a best fit line throughout the data points. Linear regression is nothing but a best fit line throughout the data points. So this is called a regression line. Regression line basically means a best fit line, right? This is called a regression line. Now, this is called a observed data points. Observed data points basically whatever that data we have. This is called an intercept, and this is called a slope. Slope of the line, this is called a slope of my slope of my best fit line size, right? And this is called an intercept. We'll talk about this thing as well, right? Intercept and slope later one. Okay, so now we have understood. In this way we have called this called a regression line. These are my data points and this is my slope, and this is called my intercept, right? That means y is equal to mx plus c. Like this kind of questions you have solved in your 10 12 standard as well, right? What will be the value of y if I have a value of x, right, based on my intercept and the slope of my line, right? Slightly slope will be changed, the value of y will be changed, right? In this way we have done in our 10 12 standards. Pretty much simple. Now let's just talk about a one simple example. We are just taking up a one simple example. So these are the libraries required for this example. We know that NumPy, how NumPy works, how pandas basically works, and this is called a matplotlib library. Matplotlib library basically used for the visualization. If I want to visualize my data, as I told, why do we require a visualization? If a non-technical person want to see my data, at that time you cannot tell them or you cannot show this code. You may be asked, okay, what it is basically, what exactly it is doing, right? You just need to show them the results based on the visualization, with the help of visualization. Okay, now let's just talk about. So this is my data set. These are the libraries basically used for this, and this is my data set. We know that how to read a data in Python, right? pd.read_csv. Okay, now so this is how we have basically get the data in Python. Okay, so this is the data set, the house data set we have. Again, let me just show you the data, what exactly data looks like. You see, this is my data set looks like, right? We have 21,613 rows or records and 21 columns in my data set. So this is my data set looks like, right? And what should we need to predict? We have to predict the price of my data set. Or let's suppose this is my price. Where is the price? This is the price. So see, this is the price of my house. So this is an example, right? So what will be the price of my house? I want to predict this one. Getting my point, guys? This is the thing, that means price I want to predict. If I want to predict the price, what it will be? It will be my target variable now. Target variable, right? A y, basically the y, right? Y is equal to mx plus c. This is my target variable. Okay, and rest are the features. Features are nothing but these are the columns, right? Columns are called the features as well. Okay, so these rest are the features will be used, or which will becomes under into independent variable or independent features, right? So we have these number of features, right? Based on, see, what will be the price based on my bedroom, what will be the price based on my bathroom, what will be the price based on the square feet of floors, waterfront view, grade, right? What is the crime rate? Many more features we have basically in this one, right? And we can get many more data features as well based on our requirement. Getting it, right? So now we have understood the data, right? And again, what I like, one thing I need to ask for everyone. So what do you think is date column and ID column? We have ID column and date column. So what do you think? These two columns would be helpful for predicting the price of my house. What do you think, guys? These two columns, ID column and date column, would be helpful for me to predicting a price of my house with the help of linear regression. No. Why? Why these are not required and why these are not important? Why? Can you give me an example, reason for that? No, these are not an important features. ID and date. Okay. Can you give me that reason why these are not important? Not dependent. Yes, because this is my not dependent.
These are the columns. ID column, it is not giving an impact on my price. Date column is not giving an impact of my price, right? Yes, this is not dependent, correct. So these are not my dependent variable. That at that time I can remove that columns as well, right? It will not give an impact on my data set. So what we are doing here, space is my one variable which I have stored a data set, square root of living. Again, now I'm going to prepare my data. I'm going to run a linear regression model on the first column only, square feet living. Square feet living, where is square feet living? There is square feet living. So I'm going to predict the price of my house based on this column only, based on this column only. You can try it out this thing as well from your end to take rest are the features. But now I'm just going to take a first feature, one feature only, square feet living. Okay. Now this thing, this is my target variable. You can say this is my target variable, or you can say the y for easy to understand. This is my y and this is called my x. This is my x. This is called independent and this is called a dependent, right? Now as we know that machine learning model cannot be trained directly to the data. We have to convert our data in the form of machine learning model requirement, right? Like the way in the array format, right? Array or matrix, you can say. So what we are doing here, we are just going to convert our space variable. Space variable is basically my values format. At that time I have converted in the form of array. Before that it is in the form of list. Sorry, it's the form of list. Now we have converted it into a array format, and we are going to reshaping it, because reshaping is required because I have a one feature only. Now the same thing I have done for y variable as well. So now you can see I have a y variable, that means a dependent variable, and I have an x, basically independent variable. Now I have a two variables. Now I have prepared my data, right? Now I have prepared my data. But this is the thing will not be happen for the real world scenarios. Real world scenarios, at that time I need to clean the data. I have to clean the data. I have to pre-process the data. I have to get ready the data for my machine learning models, right? Because this is just an example to show you how linear regression works. Okay. Now, as I told yesterday, we're just talking about the sklearn library, right? Sklearn library, as I told yesterday, it requires it takes a multiple models, right? It requires multiple models and it contains many number of machine learning models. Now, so see, there's a method from sklearn dot model selection. This is a one function within the sklearn. From sklearn dot model selection takes a train test split. As I told, before training any machine learning model, we have to split our data set in the form of 80-20%, 70-30%, 60-40%, right? But generally, a standard way we have convert 70-30% or 80-20%. Why do we require to split our data set? Why do we need or split our data set, right? Why? Because of, let's suppose I have 100% of a data. That means 1,000 records of a data I have. I am going to train my machine learning model on my 80% of my data, and 20% data will be used for checking it. Okay, how my model is performing will be tested, right? How my model is performing based on my testing data. Getting in the point, right, guys? Why do we require a train test split, or why do we need to splitting our data set before machine learning model? Why? Because 80% data or 70% data will be used for training my model. We know that, right? Any whatever that model in machine learning we will be trained on the good amount of data, right? Based on the learning, based on my data set, my machine learning model will be learned. Okay, it will be predict. Okay, it will be predict. Okay, you have trained me on this kind of a data. At that time I will be predict in this manner, right? Like the way machine learning model works, right? So we have to split 80-20, 70-30%, and after that, so see, I have imported a train test split. It will give me it will give us that four parameters, right? 4 values. So not 4 parameter, 4 values. X train basically, right? Train, X test, Y train, and Y test. Y train basically means a dependent. Y is basically nothing but the dependent, and Y is basically X train and X test. Getting it right, guys? Now, train test split and just passing of X and Y, and test side. What will be the test size? The 1/3 part, I'm going to train it, right? I'm going to train it. And random state is nothing but to randomize your data, right? Pretty much simple. What will be after that? So see, okay. Now I believe everyone gets easily see the Jupyter notebook, right? Okay. Now what we are doing, sklearn dot linear model is a function in an sklearn library which takes a linear regression model. Pretty much simple. I'm going to import it from sklearn dot linear model dot linear regression, and I'm going to linear model. I just take basically I just call a linear regression onto my variable regressor, and then I'm going to fit it on my data set. Regressor dot fit, as we know that our model will be trained on my training data, right? So here that is why I take, okay, train X train and Y train, right? After that, what we are doing, we are just going to predicting it. Regressor dot predict of X test. We are just going to predicting, right? And I'm going to predict on my test data. We know that we have to predict it onto my test data. So this is the test data. I'm going to predicting it. And after that, here I'm going to plot my data set, how it is performing. So see, I'm going to make a scatter plot. PLT is nothing but the matplotlib library, right? Matplotlib.pyplot as PLT. That means this is an alias, right? And I'm going to visualize plt.scatterplot. I'm going to pass it X train and Y train. Color should be red. At that time, I'm going to plot it. This the plot is nothing but the best fit line. Here I'm going to make a scatter plot and the best fit line, the plot one, basically the best fit line, right? And X train regressor dot predict whatever that value will be predict based on the blue lines. And the title should be this, an X label, Y label, and it will be show the values. Cross validation, basically cross validation is a part of feature engineering as well, right? Where we basically do some sort of calculation how our data is performing, where we need to check, right? Cross validation, if you can say the hyperparameter tuning as well, right? Cross validation happens in a hyperparameter tuning. If our model is not performing well at that time, we have to tune our model. Tune our model basically means we can improve the accuracy. We will try to improve the accuracy, right? And cross validation is a technique to improving our machine learning model performance. Okay. Now we have seen, right? As I told, linear regression is nothing but this is the best fit line throughout my data points, right? So let's suppose to see these are my some data points. Okay, these are my some data points. Now this is the best fit line. So what do you think? If I have a let's suppose I have a 12,000 square feet, 12,000 square feet, what will be the price of my house? The price of my house is around 5 is, you can understand, 5 lakh, 5 crore, whatever it is, right? In this way, if I have a 14 at that time, the value should be in this, not value should be this one only, sorry, 4 crore or whatever it is, right? If I have a 12 at that time, it will be around 3.5 crore in this way, right, guys? Hope everyone gets clear till this thing, right? Now let's suppose, so see, we are just going to predict, regressor dot predict. So predict, we know that predict is a method. So see, here it is showing me. Let's suppose I have 1,000 square feet. Here I have written 1,000 square feet. So I'm just passing my own value. Let's suppose I have a 3,000 square feet. At that time, what should be the value? What should be the price of my house? Okay, it is predicting the price should be like this. If I have a 4,000, if I have a 4,000 square feet, at that time, what will be the value of my house? The value of my house is this should be, right? Based on my data set, based on my whatever that I have trained my model, right? So this is how it is predicting, getting it right, right? Hope everyone gets clear till now, right? How linear regression works or how any machine learning model works. So this is how any machine learning model works, right? You just need to change some parameters based on a data set, right? Now, let's just move ahead. So now let's just see the another model, decision tree. Decision tree is nothing but this is another model of in machine learning, right? Machine learning basically it's a part of supervised machine learning as well. So now decision tree, the name already suggests decision tree. Tree basically what exactly tree is, like the way we know that tree, right? This is a tree looks like, in this way tree looks like in real world as well, right? This is a root, this is a root, and based on the root we just going to split based on the feature, sorry, or you can say the leaves, right? These are my leaves, yes, no, these are my leaves. So decision tree is nothing but the name already suggests. Try to understand decision tree in this way. Decision tree basically means where we basically make a tree based on the decisions. Again, decision tree is nothing but this is a tree which will basically build up on based on decisions. Decisions basically means whatever that decision we will made in this way, like this. If there is an outlook, if there is an outlook at that time, what will be the, so what will be the decision, okay, or you can say decision or the criteria or condition, you can say, right? So if there is a sunny, if there is a sunny season outside, at that time, let's just check the another condition. Oh, is there any humidity as well? Is there humidity? If there is a high humidity, at that time I will not go outside to play the cricket, right? If there is a forecast, definitely I'll go for playing a cricket. If there is a rainy season, another condition I'll check. Okay, if there's a rainy season, okay, let's just check the wind as well. If wind is strong, okay, I'll not go to play, right? If there is a weak, at that time definitely I'll go and play the cricket, right? So this is how decision tree basically works, based on the conditions. Okay guys, got understand, right, how it works? Now this is another example, this is another one. So see, this one, this might be decision tree. Should I accept a new job offer or not, based on the conditions? So see, this is called a decision nodes. You can, these are called decision nodes, and this is my root node. So see, salary. Let's suppose this one, salary at least this one. If salary at least this one, at that time it will be yes. If this condition gets true, at that time, okay, I'll check another conditions as well. Okay, commute more than 1 hour. If yes, okay, I'm going to decline the offer. Okay, if no, offer fees coffee. What will be, if, like, are they providing you the free coffee as well or not? If yes, they are providing me the free coffee as well with the job offer, definitely I'll going to accept the offer. If not, okay, I'll decline the offer. In these are called the leaf nodes as well. These are called the leaf nodes. Getting it, guys? Decision tree is nothing but the structure of a decision tree looks like a tree based on the criteria, based on the conditions, right? These are the conditions I have. This, if this condition gets true, at that time I'll go this side. If this condition gets false, at that time I'll decline the offer. Like this, right? A true false kind of a condition, simply. Right, everyone? Hope everyone gets clear till now. The another image I have, another image. Now, if a age is less than 30, if a age of a person is less than 30, it will check, okay, that person can, if a person of no person, if a age of a person is less than 30, at that time, if yes, if it's less than, at that time, shall we eat the pizza? If yes, that means there are highly chances the person is unfit, right? If a no, at that time, that person would be fit, right? If a person is greater than age of 30, at that time, that person giving like doing exercise. If yes, at that time, that person would be fit. If no, at that time, that person is unfit, right? There are two conditions, fit or unfit based on the different conditions, right? Okay, now we have understood. So decision tree is an algorithm which can solve a classification problem and regression problem. Both the problems decision tree can solve. We have understood, right? Regression problem or linear regression is a regression which can solve a regression problem only. But decision tree is a model which can solve a classification problem and regression problem as well, right? Classification problem, we know that, right? Where we have a conditions, where we have a two criteria, where we have a two classes, whether I'm going to fail, whether I'm going to pass, fit or unfit, like this. Or if I have a continuous data at that time, that means a regression problem. Decision tree can solve regression and a classification problem both. Now, and another question comes arise, basically how decision tree basically split these features. How decision tree basically get to understand how it should be splitted. How decision tree basically will understand how this will be predict or how this will be split based on different conditions. Let's suppose I have a 10 columns, I have a 10 features in my data set, right? How decision tree is gonna be understand automatically what feature should be come above, and after that what would be the another feature should become, right? This is my first feature, right? If a person of a age is less than 30, another column will be checked if the person is eating a pizza or not, and another condition if the person is doing exercise or not. This is my first feature, this is my another feature, or this is my third feature. How decision tree is get to know based on these things: information gain, entropy, and Gini index. So these are the three conditions, or three, you can say, the algorithm in decision tree basically get to understand whether a person is fit or unfit based on these three things: information gain, entropy, and Gini index. I'm not going to discuss these things because it takes a lot of time. So now you can understand in this way. Decision tree basically split the features. Decision tree split the features based on these three things only: information gain, entropy, and Gini index. The formula of entropy, this one, entropy is equal to summation of minus p multiplied by log of p, right? A person is fit or unfit based on the conditions, right? This is the formula. So now we have understood a basic overview of decision tree, how it is gonna be split up features based on information, or interviewer, or someone if you ask you, right? What like how decision tree basically split the features. A interview sometimes asks, right? How decision tree split the features based on these three things: information gain, entropy, and Gini index, right? And sometimes he may be asked, okay, what's the formula of Gini or Gini or entropy formula? What's the formula of entropy? What's the formula of Gini index? In this way, right? The difference between Gini index and entropy. This is the way, right? Hope everyone gets clear about decision tree, right? Everyone, can you please guys confirm once? Are we clear till now? Shall we move ahead about decision tree? Okay. Okay. Now let's just talk about a example of a decision tree. Okay, now import pandas as PD, import matplotlib as PLT, right? This is my data set. I'm just going to read. Again, this is my data set of a table format. Table format basically means TXT format, a text data we have, right? Now I have a text data, not a CSV, not an Excel file, right? That is why I'm just taking, as I told yesterday as well, right? Whatever that data I have, based on that I have a functions in pandas, right? If I have a Excel data, at that time I have a read underscore Excel. If I have a CSV file, I'm going to read at that time read underscore CSV. If I have a TXT file or text file, at that time I have a read underscore table. Just always remember, you have to write it the extension. What would be the extension of a file? It is .txt, .csv, or .xlsx or xls, right? This is how. And we know that how, like what exactly fruits dot head does, right? So this is my data set looks like. Okay, now, so see, we have these kind of features: fruit label, fruit name, fruit subtype, mass of a fruit, width of a fruit, height of a fruit, or color score. What with the color score? Okay, so now how many unique we have? How many unique fruit name? Okay, this is my column name, right? This is my column in my data set. So fruits is my column or it's my data frame. In this data frame, how many unique? So unique is a method which will give you the how many unique fruits I have. Apple, mandarin, orange, and lemon. They are 4 fruits I have, right? Okay, now we have understood we have 4 unique fruits. Okay, and what we are going to predict, let's just see this thing as well. And what would be the size? Fruits dot group by. Group by is a method or it's a technique like the way we have in Excel as well, a pivot table. Again, group by in Python is a similar like the way we have in Excel a pivot table, right? In pivot table, we can summarize things easily, right? Easier way. The same process we have a group by in Excel and Python as well, a group by, right? Now we are just going to see the size, size, right? Fruits dot group by fruit name. This is my fruit name, and what would be the size, right? Let's suppose this is my column name. Fruit underscore name is my column name, and apple comes 19 times, lemon comes 16 times, mandarin comes 5 times, orange comes 19 times, right? This is the size of my data set. Okay, now as I told, if you want to see or if you want to show your data set to your manager, to anyone, any person which don't know about a coding and all that stuff, visualization can help you. And Seaborn is a library. We have a 2 libraries, right? We have a multiple libraries for sure in Python: Plotly, Seaborn, Matplotlib, right? Many more. But there are another library of visualization. The first one we have talked about, Matplotlib. Another one is Seaborn. And as SNS, we know that what exactly as SNS is. I'm going to make a count plot, SNS dot count plot, fruits of fruit name, and the label should be count. So see, it is showing me, okay, apple we have, okay, like what will be the, like what are the highest count of my fruits? We have apple and orange. Okay guys, now we have understood in this way. Now everyone gets clear till now, right? What exactly it is, right guys? Okay, now let's just move ahead. Okay, now features of my feature names. Feature name, right? These are my column names. And what are the feature names? I'm going to build my decision tree model based on my 4 columns only. So see, this is my data set looks like. What do you think, like fruit subtype would be helpful for predicting a fruit name or fruit label? Let's suppose I'm going to predict in this data set what would be the label of my fruit, whether it is 1 or 2 or 3 or 4, whatever it is, right? A label of my fruit. Getting my point? A label 1 is nothing but a apple. It will predict a apple. A label 2 is nothing but a mandarin. A label 3 would be orange, and label 3 would be lemon. If it will predict a 4, that means it is predicting lemon, right? In this way. Now, and what do you think? This is a classification problem or this is a regression problem? Can guys you confirm me? Is this a classification problem or it's a regression problem? Because I want to predict the fruit label of a fruit, whether it is 1, 2, 3, or 4. What problem? What type of problem it is? Classification problem. Yes, this is a classification problem because we have a classes in my data set, right? Yes, guys. Yes, this is a classification problem for sure. Now, let's just move ahead. So, okay, now we have understood. We are going to predict a label of a fruit based on the mass, based on the width, based on the height of a fruit, based on the colors, right? These are the features we have. So now, what do you think? This is my independent features, right? X is nothing but my independent features, and Y is nothing but my dependent features. Dependent, right? Or target variable, you can say, right? So now I have taken a fruit is my data frame, fruit label only, and rest of the features comes under into X. Okay. Now we know that how to do that. From sklearn dot model selection import train test split, right? We know that before making any model we have to split our data set. After that, train test split X comma Y random state, anything we can do. We are just training my data set. And after that, from sklearn dot pre-processing import min max scalar again. These are the min max scalar, whatever that thing. There are multiple techniques we have where we basically scale our data. These comes under into data pre-processing and feature engineering as well, right? Now we are not going to discuss about more feature engineering and data pre-processing, right? The min max scalar, if we have a continuous data, if I have a continuous data in my data set, at that time I need to use a min max scalar technique. There are multiple techniques as well, but now I'm just using a min max scalar. Min max scalar basically range of my data set within a one same range, right? That will be helpful for my machine learning model to predict easily. That is why. Okay, we will discuss these things later in depth. Now I'm going to use this because I have a continuous data in my data set. Okay, this is why I'm doing this. Okay, after that I'm just going to fitting it scalar dot fit underscore transform on my train data, and I'm going to transform it. After that I'm using a from sklearn dot tree is nothing but my class, or you can say my parameter or function of my sklearn, which contains a decision tree classifier. Okay, I have imported decision tree. Now decision tree classifier on the same line, I'm just fitting it on my train data. After that we can check, we are just going to check the score, right? How much my model is scoring, or you can say the accuracy, right? The accuracy of my decision tree on training data set is nothing but one is nothing but the 100%. On a training data my model is performing, giving me 100% accuracy, and on the test data it is performing 87% of an accuracy, right? This is problem comes under into, right, on you can say overfitting and underfitting type of a problem. We are not going to discuss that thing in depth, right? But these are the problems I have, overfitting and underfitting problems related to in same as overfitting and underfitting problems, right? We will discuss overfitting, underfitting after some time. But now we are going to understand in this way. Min max scalar is nothing but, guys, min max scalar basically range my data set within a specific range. If I have a wide data, if I have a wide data which has a higher variance, right? You can say a huge gap of my data set. At that time, my model will not be trained better. That is why I just need to require a min max scalar. There are multiple techniques as well, right? You can understand this way like this only. Okay, the min max scalar right now. Okay, now, okay, now. So now we got an 87% of an accuracy. Someone is asking about why it is not showing 87% directly. Just need to multiply by 100. It will be give you, right? Just multiply by 100. It will give you the 87% of an accuracy. Right, guys? Okay, multiply in this way. It is predicting and something else. Okay, it is predicting everything in this. Okay, now we don't need to multiply this here. Okay, it will be work, we need to multiply here only, right? Okay, you can understand, right? We just need to multiply by 100. Okay, now we don't have, okay, now we have 73% of an accuracy, not an 87, right? I have run this file before, that is why we have just different accuracy now, right? Okay, now we have understood, right? Now let's suppose I want to predict like this. Let's suppose I have a CLF, okay, CLF, and I'm just checking it, right, from my data set. Must training set accuracy and test set accuracy should be the same? No, that should not be same, guys, right? This comes under into, right, overfitting and underfitting type of problem, right? It should not be same. So predict is my method which takes a 4 inputs. We have a 4 inputs now, right? Why we have a 4 inputs? Because we have a 4 independent variables, right? We have a, if I just check this one, see, I have a 4 features: mass, width, height, and color score. Let's suppose I'm just writing a some random number from my end. So I'm writing 200, right? The mass of a fruit is 200 from my end, right? And the width of my fruit is around 12, right? 12.0. Let's say 12.0. And the height is around 10.0 or 10.1. 10.1, right? Comma, the color score should be 0.67, right? It is predicting me 3. What's the meaning of 3? 3 meaning is basically nothing but this is 3. This is 3. That means the orange, the label of a fruit is 3. It is predicting 3. Getting it, guys? The predicting is 3. In this way, yes, orange it is predicting. If I just change this one, if I just do this 250, the mass of this one, it is predicting the same. If I just did this 15, it is predicting same. If I just did this 13, same. If I did this 0.99, same. That means it is predicting 3 for the class. Third class, it is predicting based on my data, right? Now we have understood this thing, right, guys? This is how it is predicting the thing. Someone has a question? Yes, definitely, guys, right? Guinea impurity, Guinea impurity, entropy, these are the things, is nothing but Guinea impurity is like Guinea impurity, entropy. These are the models or these are the techniques can help us to split my data set on a better format. Again, Guinea impurity, Guinea impurity, sorry, not Guinea impurity, Guinea index, entropy, and information gain. These are the 3 techniques basically helps us to split my data set in the proper way. Like what should be the first column, right? What should be the next column? What should be the third column? I have 100 columns. Let's suppose I have 100 columns in my data set. So how do you get to know what should be the first column, what should be the third column, what should be the last column, right? Based with the help of entropy, Gini index, and information gain, we can understand what should be the first column, right? First, well, like based on like first column should be split this one in this way, like this, like this. The hierarchy, you can say, based on the hierarchy, based on the columns features. Yes, if we are not getting a good accuracy, again, some advantage, some disadvantage we have as well, right? So now we have understood a decision tree, right? So if our decision tree model is not performing well, or there are highly chance most of the time decision tree gets be overfit, right? It mostly sometimes not sometimes, mostly it gets overfit if we have a huge data. If I have a huge data, at that time there are highly chances my decision tree model gets be you can say overfit, right? It will, the accuracy of my decision tree model will not be good, right? At that time we can use, there are some more techniques to improve the accuracy of my decision tree. What? We can use a random forest, right? What exactly random forest is? Now let's just talk about a little bit about a random forest. A random forest is nothing but there is an advancement of decision tree. Again, random forest, the name already suggests decision tree is nothing but, in decision tree we have one single tree, right? Again, decision tree, the name already suggests, I'm just connecting those model names throughout the names only, their names only. Decision tree is nothing but there is a one single tree in decision tree. But in random forest we have a multiple decision trees. So see, the name already suggests forest. What do you think? In a one forest, in a one single forest, how many trees we have? We have a multiple trees, right? Decision tree, it's a one single tree. In random forest is nothing but we have a multiple decision trees. That means Random forest is a model which will basically build upon a multiple decision trees. Random forest is a combination of multiple decision trees. Getting in, guys? And random forest is a model which will basically solve a overfitting problem of a decision tree as well. If our decision tree model is not performing well, or it is giving you not, it is not giving you the good results, or it is overfit, at that time random forest is another model which will basically comes for to solving this overfitting problem of a decision tree, right? And the another technique for decision tree is a pruning, right? A pruning technique. And there are highly chance a decision tree will be overfit if I have a huge data set. My decision tree model gets be overfit. The meaning of overfitting is nothing but my model is not performing well. We'll go deep dive overfitting, exactly what exactly overfitting, underfitting, these other stuff. Overfitting is nothing but my model is not performing well. It is not giving you the good results, right? At that time, what do we need? We just need to use a random forest or a pruning technique. Getting it, guys? In random forest, we have a multiple decision trees. Okay, now let's just read about this thing as well. Random forest is a supervised machine learning algorithm. It has two variations. One is used for classification problem and other is used to regression problem. Yes, like the way we have in decision tree can solve a classification problem as well and regression problem as well. Like the same one we have in random forest as well. Random forest is a model, is a combination of multiple decision trees, and it is basically can solve a regression and classification problem both. Okay. So basically, other than decision tree, other than regression, we can use a random forest as well. In supervised machine learning and unsupervised machine learning, we have multiple models, right? We have XGBoost as well, right? Some people said XGBoost, AdaBoost, multiple models we have. So we can use a random forest, decision tree, right? Linear regression, logistic regression. These are the models we have. SVM as well. Yes, we can use SVM as well. These are called a classifications model. Okay. So random forest is a model which can solve a classification problem and regression problem as well, right? KNN as well, right? KNN also can solve a classification problem, yes, but it not perform well on a big data if you have a huge data, right? Now, what is the intuition of random forest? I have already told, right? What is the intuition behind a random forest? A random forest is a model, is a combination of multiple decision trees. Okay. Now, what's the it's called an ensemble technique as well. Again, it is called an ensemble technique as well. Ensemble technique basically means the name always suggests ensemble. It comes under into ensemble a multiple decision tree in itself. That is called an ensemble technique. Okay, it combines multiple decision trees. So see, I have written it's a combination of multiple models. That means the trees. The first one, it combines multiple models. That means trees. Okay, another one, it's called a bagging. Random forest is a model which uses a bagging technique, a bootstrap aggregation we generally call bagging technique, right? What exactly bagging technique is, definitely will let you know that thing as well, right? For later one, bagging technique. Random forest is a model which uses a bagging technique to solve the overfitting problem. Okay, raw sampling with replacement, replace those which is not important for prediction. These are the steps random forest does to solve a overfitting problem. Feature sample and raw sampling random forest does. Okay, random observations to grow each tree, random variable selected for splitting at each node, randomly selecting a sample of a data, right? Random subset of features. So these are the things random forest does for solving a overfitting problem, right? Everyone, right? Based on these kind of techniques, random forest does. That is why it solves a overfitting problem. Okay. Now, what exactly the overfitting problem is? In overfitting, we have a low bias and high variance, right? Low bias and high variance on a training, testing data kind of stuff. Whenever we are going to discuss in depth overfitting and underfitting problem, at that time we'll discuss that thing as well. Okay. Okay, guys. Now let's just move ahead. Okay, how it looks like, as I told, random forest is a model which contains a multiple decision trees. Multiple decision tree basically means in decision tree we have a one single tree. In random forest we have a multiple decision trees, right? Let's suppose this one as well. This one. So see, this is my first decision tree. This is my second decision tree. And this is my third decision tree. And how random forest works? Random forest basically works on a majority voting. Again, what's the meaning of majority voting? The name already suggests majority. Let's suppose I have a 3 decision tree in my one random forest. I am applying a random forest. I am applying a random forest, and we know that random forest, it's a combination of multiple decision trees, right? So in this random forest, I have, let's suppose, 3 decision trees. One decision tree is predicting this is a class B. That means it is predicting this is a banana. Another model or another decision tree is predicting, okay, this is a class A. That means an apple. Another one is also predicting this is a apple. So it will take a majority of a voting. Okay, it will be understand. Okay, 2 decision tree are saying this should be apple. At the end of that, this random forest will predict, okay, this is an apple, because majority of the decision trees are saying this is an apple, not an banana. Getting it, guys, right? If I have a 10 decision tree in my random forest, 8 are predicting, or 6 models are predicting this is an apple, not a banana. So random forest take a majority of the voting. Okay, 6 are saying this is an apple. Okay, at the end it will predict, okay, this is an apple only. This is how random forest works, right, guys? Clear till now what exactly and how random forest basically works? At the final class it will predict. This is an final class, right, guys? Are we clear till now? Okay, so see, this is a one, it looks like decision tree 1, decision tree 2, decision tree n. It is predicting class 1, and after that majority of a voting for classification, average of regression. Again we know that random forest can solve a regression and classification problem both, right? Majority of the voting it will take for classification problems. If we are solving a classification problem, for majority voting, at that time it will take a majority voting technique, right? If we have a regression problem, if we are going to solve a regression problem, at that time it will take an average. Okay, there are two things. Majority of the voting random forest will use for classification problems. Average voting, or you can say the average only, average it will use for regression problems if we are going to solve. Okay, there are two things. Understood, right, till now? So these are another image, right? Random forest classify how it looks like. Oh, decision tree 1, 2, 3, 4. Majority of the voting for classification problem, right? And it will take a regression, not regression, sorry, it will take a average for regression values. Now we understand, right? What are the benefits, advantage, disadvantage of random forest? I have written everything in this, right? Random forest can be solved for classification, regression problems, right? Everything I have written in this way, everything. What exactly difference between random forest and decision tree? Random forest is a set of multiple decision trees. We know that decision trees are computationally faster as compared to random forest. Yes, decision tree is basically computationally faster other than random forest. Why? Because in decision tree we have a one decision tree only, but in random forest we have a multiple decision tree. Because of this only, deep decision tree may suffer from overfitting problem. Yes, we know that how to solve an overfitting problem if I have in decision tree with the help of pruning technique, with the help of using a random forest. Random forest basically prevents decision tree by overfitting, creating trees on random forest. Okay, random forest is difficult to interpret, but a decision tree is easily interpretable and can be converted to rules. There's a meaning of this. So we have discussed so far, we have discussed three models today: linear regression, decision tree, random forest. We have understood how decision tree works, how random forest works, a basic overview, and how linear regression works. Are we clear till now, guys, right? So for sure, for today's one, we'll share the quizzes as well, right? Related to machine learning models and all that, for sure. Okay, great, guys, great. Okay. So this is it for day 3. We have covered a lot of stuff today. We have talked about multiple stuffs. For tomorrow's one, we are going to start a project, you can say, right? Okay, guys. Okay. So that's it for today's one. We'll meet tomorrow, guys, for the same time. Thank you so much, guys. Thank you. Okay, guys. We'll meet tomorrow. If you have any kind of question, you can ask meanwhile then. Thank you, guys. Thank you. Yes, tomorrow we are going to start the project only. Project basically means from a project where we apply everything, a machine learning model, some pre-processing stuff and all that. Seaborn is a library basically used for the visualization, like the way we have Matplotlib, right? For sure, we'll share this project, not project, the code for practice. Definitely, we'll share that thing. Thank you, guys. Thank you. Thanks for joining. Bye-bye, guys. Take care. Definitely, we'll upload the Jupyter notebook, guys. And try to solve the quizzes we'll share today. Definitely, we'll tell you the requirements as well, guys. Definitely. Thank you, guys. Thank you. Bye-bye.